Have you ever wondered what the weather is like on Mars? This intriguing question has captured the imaginations of scientists and space enthusiasts alike for decades. Our neighbor in the solar system, Mars, often referred to as the Red Planet, boasts a unique atmospheric composition unlike any other. The Martian atmosphere is razor-thin, a mere fraction of what we're accustomed to here on Earth. It's composed primarily of carbon dioxide, with the occasional trace of other gases like nitrogen and argon. The scarcity of these atmospheric components creates an entirely different weather system that's fascinating and complex in its own right. This thin atmosphere plays a pivotal role in shaping the Martian weather. The lower atmospheric pressure means that heat doesn't get trapped as it does on Earth. This results in more extreme temperature variations and other weather phenomena that are unique to Mars. From dust storms that can envelop the entire planet to ice caps that expand and contract with the seasons, the Martian weather system is a mesmerizing spectacle of nature's power and variability. Understanding these weather patterns isn't just about satisfying our curiosity. It's a crucial piece of the puzzle in our quest to explore Mars and potentially establish a human presence there. Every dust storm, every shift in temperature, every change in the Martian weather system provides invaluable insights into the planet's climatic history and potential for future habitability. But the Martian weather is more than just a scientific curiosity. It's a testament to the incredible diversity of our solar system and the mysteries that lie beyond our own planet. It's a constant reminder of how much we have yet to discover and how much we have yet to learn about our neighboring planets. So the next time you look up at the night sky and spot Mars, remember that it's not just a red dot in the cosmos. It's a world with its own unique weather system, a world that continues to challenge and inspire us with its enigmas and complexities. Understanding the weather on Mars is like assembling a jigsaw puzzle, with each piece contributing to the broader picture. Imagine a storm so vast it engulfs an entire planet. On Mars, this isn't a flight of fancy. It's a meteorological reality known as a dust storm. These storms are a spectacle of nature's power, where fine particles are lifted from the Martian surface by powerful winds, creating a whirlwind of dust that can shroud the entire planet. Their occurrence isn't random. There's a seasonal rhythm to these dust storms, a pulse that beats with the Martian year. During the southern hemisphere's summer, the planet warms up and the wind gets stronger. This is when local dust devils can grow into regional storms, or even balloon into global phenomena that block out the sun. But what drives these winds? Mars' thin atmosphere and its varied topography play a significant role, with temperature differences stirring up gusts that can lift the dust into the air. These dust storms, from dust devils to global phenomena, paint a dynamic picture of Martian weather. Mars, like Earth, experiences the rhythm of seasons. On the Red Planet, these seasonal changes have a profound impact on its polar ice caps. These caps, a blend of water ice and dry ice or frozen carbon dioxide, play a pivotal role in the Martian climate. During the Martian winter, temperatures plunge, causing a portion of the thin carbon dioxide atmosphere to freeze, expanding the size of the ice caps. But as the planet tilts towards the sun and spring emerges, the caps recede. The dry ice sublimates, transitioning directly from a solid to a gas, and is released back into the atmosphere. This cyclical dance of expansion and contraction not only paints a captivating picture of the Martian seasons, but also offers invaluable insights. By studying these dynamics, scientists can decode clues about Mars's past climatic conditions and atmospheric evolution. The dance of the Martian ice caps offers a window into the planet's climatic history. Mars is a world of extremes, especially when it comes to its climate. It's not just the red dust that makes this planet unique, but the stark contrast in its temperature range. Imagine in the course of a Martian day, experiencing temperatures that swing from the heat of a summer day on Earth to the bitter cold of an Antarctic winter. This is the reality on Mars, where the diurnal temperature variation can be extreme. Near the poles, temperatures can plummet to a startling -195 degrees Fahrenheit. That's colder than the coldest temperature ever recorded on Earth. And it's not just the cold that's extreme. In the equatorial regions, temperatures can soar to a toasty 80 degrees Fahrenheit during the summer. These climatic extremes, from biting cold to blistering heat, are largely due to Mars's thin atmosphere, which does little to retain heat. These extreme conditions present a formidable challenge to future human exploration. Even in the thin Martian atmosphere, clouds find a way to form. Like celestial apparitions, these clouds whisper tales of the planet's unique atmospheric dynamics. They're composed of water ice crystals or dry ice particles, depending on their altitude and the prevailing temperature conditions. Unlike Earth, where clouds are typically formed by the condensation of water vapor, Martian clouds have a more frigid origin. The extreme cold temperatures allow for the condensation of carbon dioxide, creating clouds of dry ice. These clouds tend to form near the planet's equator during the coldest times of the Martian year. On the other hand, water ice clouds are more frequent, often appearing at higher altitudes. They're seen more often during Martian spring and autumn, when the planet experiences its coldest temperatures. These Martian clouds, in all their ethereal beauty, play a significant role in the planet's weather patterns, influencing temperature variations and wind circulation. These Martian clouds offer a unique perspective on the planet's atmospheric dynamics. Methane, a gas often associated with life on Earth, has been detected on Mars. Yes, you heard that right. Methane on Mars. This intriguing find has sparked a flurry of questions and hypotheses. The curious case of Martian methane begins with its detection in the planet's thin atmosphere. But it's not just the presence of methane that's interesting. It's the fact that it appears in localized plumes. Picture this: invisible methane clouds wafting through the Martian air. So, what's the big deal about these methane plumes? Well, on Earth, methane is often produced by biological processes, hinting at the tantalizing possibility of microbial life on Mars. But before we get too carried away, it's worth noting that geological processes, like volcanic activity or chemical reactions in rocks, could also be the source. Regardless of its origin, the presence of methane adds another layer to the complex puzzle of Martian weather. Mars is a world of diverse landscapes, and each plays a role in shaping its weather. The planet's topography, with expansive canyons, towering volcanoes, and vast plains, has a significant impact on its atmospheric dynamics. The Martian landscape influences local wind patterns, guiding their flow around towering features and across broad plains. These winds not only whip up the planet's infamous dust storms, but also contribute to daily and seasonal temperature variations. In the vast canyons, for instance, the wind gets funneled, increasing its speed, while the towering volcanoes can create wind shadows, causing calm areas on their leeward sides. At the same time, these massive geological structures can also act as thermal barriers, leading to significant temperature differences across small regions. It's the interplay of these elements that makes the weather on Mars so unique and complex. The interplay between topography and weather adds to the complexity of Martian meteorology. The quest to unravel the mysteries of Martian weather continues. As we speak, ambitious missions are in progress, with more planned for the future, all aimed at enhancing our understanding of the red planet's climate. The Mars Science Laboratory, for instance, is already hard at work, equipped with sophisticated instruments to monitor and analyze Martian weather patterns. But that's not all. The upcoming Mars Sample Return mission is set to take this research a step further. It aims to gather and return samples from the Martian surface to Earth, allowing scientists to study them in detail and refine our knowledge about Martian meteorology. This mission, like those before it, underscores the critical role that weather monitoring plays in our exploration of Mars. These missions represent humanity's relentless pursuit of knowledge about our cosmic neighbor. And who knows? The findings from these missions might just bring us one step closer to setting foot on Mars ourselves one day. The study of Martian weather is more than a scientific endeavor. It's a journey that unravels the mysteries of a neighboring world, a world that might one day host human life. From the thin carbon dioxide-rich atmosphere to the towering dust storms, the weather on Mars is as fascinating as it is complex. The polar ice caps, with their seasonal dance of expansion and contraction, offer a window into the planet's climatic history. And let's not overlook the climatic extremes, the Martian clouds, the mystifying presence of methane, and the influence of an awe-inspiring topography. Each of these elements shapes the weather on the red planet, and understanding them is key to any future exploration or potential colonization. As we continue to scrutinize Mars through the eyes of our advanced probes and missions, each discovery, each unraveled mystery brings us one step closer to understanding our place in the cosmos.